Thank you. Okay, Neil, we can see you coming down the ladder now. Okay, Neil, we can see you coming. I'm at the foot of the ladder. The lamb footbeds are only depressed in the surface about 1 or 2 inches. Although the surface appears to be.
I'm James Reed and I've been allocated the team manager for this project, and I'm from a company called Bombardier. Today we're demonstrating the working principle of this mechanism, which a key task is to get to 1,000 metre altitude. For this model we decided to use the integration of two ideas, using initial compressed air for our initial launch and then activating the rockets momentarily after to allow us to ballistically fly to 1,000 metre altitude. We've made use of the materials we have available for us, using the lunar rover wheels as gyroscopes to stabilise us during this effect, and when we're at our 1,000 metre altitude it will be displayed by the 7-segment display and the Doppler effect shown on our model. So as explained, the gyroscopes will first be activated, which have been obtained from the lunar rovers. Through doing so, 3, 2, 1, the compressed air will be released and the rockets will be activated, allowing us to ballistically fly to a 1 kilometre altitude. This, as said, will be displayed on there. In the event that our rescue mission is slightly late or doesn't arrive, we've had a contingency plan of allowing ourselves to elevate back down, increment in the rockets to allow us to a slow descent and resetting the platform ready for a second launch.
The challenges we faced was that in the initial stages we came up with 3 concepts. The 3 concepts were a lunar tether, an air launch platform that used hoses, and this concept. The difficulties with the other 2 was the lunar tether would have to be about 32,000 kilometres long within the 5-day time frame. It's unfeasible to make that amount of rope basically. The other one was, again, with the 1 kilometre hoses, that would be too long, we wouldn't be able to make them, so we actually integrated the air into this one as well. So we used the air because in the brief we had an abundance of air, we used the air to launch the platform initially and then used the descent propulsion system from Apollo 17 to rocket power the rest of the way, and then, as Jim said, ballistically fly the rest of the way.
You sort of realise, achieving a task like this, how crucial teamwork is. By sort of good planning and making sure everyone does the roles they're supposed to do, a project like this can come together so quickly. And it's good also utilising sort of each member for their strengths, and when you know someone's weak in one area, to utilise another person who's strong in that area to do the task which they know they're sufficient to do.
I've learnt personally and as a group quite a lot about programming pickaxe ICs, a lot about electronics. We had a few teething problems with the electronics and the circuitry, so we had to troubleshoot all of those. It was a steep learning curve, we'd not done it before, so we all came together for that. Also, what we would do differently is next time we would probably, now we know a little bit more about electronics through this project, we would actually probably put some sort of simulation of a rocket on the bottom of the base itself, the rocket platform itself, because at the minute there's not anything there.
Well, I think this is sort of a good demonstration because our model relies heavily upon using sort of materials available to us on the lunar surface, and what we've ended up doing is stripping a lot of components from the pre-existing lunar modules through a lot of extensive research and managed to remanufacture them into a working component. And I think that sort of culture and aspect can be embraced in sort of real working life, because at the moment, obviously with recycling and how important it is in fossil fuels, this sort of concept and culture can be integrated into sort of a modern day society.
Bombardier are quite heavy on that as well, aren't they? So that's something we brought from the company as well. So.
It's 1 small step for man, 1 giant leap for mankind.